sure, man. Ain't nobody behind, even nobody behind. Only way one left behind. If they stay behind, they sell.
I
Hey,
um I
uh,
almost go on the bed and ain't even eat last night.
I tell you, put that kind of stress on yourself now. I don't listen. Don't cause me get charged from. You pass it out on me. Don't do that. Come on, man. It's serious, right? So come on. Yeah, I know it can get like that sometimes. But that's the good stuff. That made something seeping in, believe it or not. That's what that made. So let's give folks another, yeah, man, another minute or so. Let's give folks another minute, and then I'll jump right in. Get started. If you don't have already, if you could actually find one of those question 4 papers, not the one from last night.
I think that one actually had two on it.
Two? Okay.
Yeah, I can double check it right now.
Okay.
Uh, yeah, that's two on it. So the one we looked at was the one all the way to the bottom. This next one is like, what is this? Second to last page. Yeah, page 7.
All right, so we probably could use that one. And like I said, the concept of interpreting the code is basically the same. Just the numbers that will change, and so I'll go through that.
All right. Mr. Davo, when we was talking about the apartments and the single dwellings, when we speak on that yesterday, you were saying that we usually get the duplexes down here confused with apartments. They're actually you call them row housing.
The row housing, that's correct.
So they still fall under the 200
Right.
rule when it comes to measuring it out, the voltage.
That's correct.
Okay. Mhm. So, and generally when it comes to the apartments, normally all of their heating systems are all connected to each other.
And the majority the big ones, like when you, for example, if you think about, let's use something that is common. Let's use so you're going over the bridge, and you're right on the, you know, them pretty buildings on the side of there. So you're going over the bridge, you come through the toll, and a little forget it, Harborside Marina. You see Harborside? You familiar with Harborside?
You talking about? You talking about?
No, I talk Harborside when you're going over the bridge. Harborside, we have all those big buildings and stuff. Well,
You
think about
talking
a
about
park.
Nassau?
You
Yeah,
talking about
Nassau.
Nassau, Mr. David?
Nassau, yeah, I forget.
Hey,
Sorry. All right, so let's think. All right, so you're in Freeport. Let's think about let's say you opposite the bazaar
yeah,
in Grandma. You know them big apartment complex there?
right.
So if you look at them, they probably have two pumps, but one water system,
Mm.
one big tank. They probably may have a shared swimming pool.
Yeah.
Right.
From the point.
You're right, stuff like that. So that's your apartment complex.
Yeah.
You see, and even in some cases, their gas supply is one big tank. You see, that's what I'm talking about when we're looking at defining the difference between row housing and and a apartment complex. And even though the calculation for the square footage is the same, for example, when you look at the apartment, section 8202, it actually tell you that the first 45 meters is 3,500 watts, and the second 45 is 1,500. You put 45, that give you 90. And you put the 35 and the 15, that give you the 5,000.
Yeah.
So it's basically the same. And if you look at it, interpretation, there's some difference, like when you look at the loading and how you deal with the loads. For example, I shared with someone, we talk about the range. So if I'm looking at a range in a house and I have multiple range in the house, I deal with them. I get the code from section 8300, allow me to add them up. Allows me to add them up and then go ahead and utilize, which one is the greater. So that's some of the difference with it.
Oh. E300, gotta look back over that.
Yeah. So I have one of my persons on so far. 10 more minutes. Now let's go right into it.
Okay, see now.
Hey, Mr. Davo.
Yes, sir.
Hey, what topic y'all went through last night? Because I couldn't make it for class last night.
All right, we went over question number 4.
Yeah.
But I taken it from start to finish. So if you didn't show last night, like I expressed earlier, so Tuesday class is a given class.
Yeah.
Wednesday and Friday is a must. So I'll go over it. I'll go over everything we done on last evening.
Okay then. Thank you.
No problem. All right. I also asked team last night to look at what is grounding. Grounded. And so if you look at section 0 in the code or page 61, that helps to give you a definition. We could talk a bit about that. I would want everyone to pull out a question 4. A question 4. I would have sent. I have a presentation. I didn't send it last night. I'm going to be hard up on the board. I'll pull that back up. I'll pull that back up. Open it up. I'll pull that back up and actually use this. I'll send you this. I'll talk a little bit about this. We would have actually talked about how we could look at this, the calculation of a single dwelling, how we can make it a little easier. I'll send this out and you'll see how we actually took this and rolled right into question number 4. I'll give the others another, I say, we're supposed to be going 6 o'clock, it's 11. I give another 3 minutes. Another 3 minutes, and I'll get started. So make sure you can have a question 4 paper in front of you. Question 4 paper. Mr. Store, I'll call you to give me the details of that question paper. Let me get some more markers. You want to have your code out as well. You want to have your code. Have your code. You want to look at section 8, section 8200. All right, so it's my clock say so 6:13. I will get started at 6:13, so I'll get started. So again, good afternoon to all. Last night class, I want to apologize, Mr. Turner. I hope I ain't blowed no fuse. So I know that was some tough stuff. I had only planned to get you through 1D from section A, recap that 1D and 1C, and then go into question 4 from section B. And I only wanted to do 2 parts, but I had one question 20 minutes right before I wanted to stop. So the adrenaline got pumping, folks got interested, and then 18 minutes after that, fuse started blowing. Fuse started blowing, and so I want to apologize for that. But we can dive directly back into it. And so good afternoon. I see we have Ms. Thurston here this evening. Ms. Thurston, welcome. For folks who was in here last evening, even though you missed a nice session, I will go over, Mr. Joseph, though the contents would we would have actually gone through. And so you should have a question 4 in the front of you. You should have your code book. I can go through just this little bit and I'll send this presentation. I think I may have already sent it. Someone asked for it last evening, so I'll send this presentation again. It just gives a little basic step on how you do the house calculations. Why are you switching? How you do the calculation for the house? She ain't changing for me. Let me stop. See why she stopped sharing. Let's go back. And the screen isn't moving. There we go. So let's see, make sure she's moving. Okay. So terms, remember, say load. Load is the level of electrical current flowing through a wire or a conductor. Maximum load, the highest level of electrical current flowing through a conductor or wire. And I like to say, let's get familiar with the right terminologies. It's important. Could help us to remember. Again, B2BI mission is to prepare our students to be globally competitive. So as you build your vocabulary, we're saying conductors, a conductor. And so the demand is the level of electrical current required by a single piece or grounding of electrical equipment under normal operation conditions. Then we went about the this here, and this is very crucial to us in understanding how we interpret the single dwelling calculation steps. And so you will get this presentation. And so according to the Canadian Electrical Code, rule section A200, step one, say calculate demand according to the sub-rule, or according to sub-rule A. So if you have your code book open up, it tells you how you address that. And what I would have done last evening, I just reflect on the total area that we came up with, the calculation that we did on Friday, where we had an area of 150 meters squared. And from that 150 meters squared, we was quickly able to go to execute the calculation of the total watts for the area. So if I say we have an area of 150 meters squared, somebody can tell me what the total watts will be. And I'm getting all this from section A200. Somebody can tell me that. Come right in. Yeah. Only some folks came early and the door was pulled to.
Will you say 100 and how much meters?
150 meters.
How many? Okay. That would be 6,000 watts.
I have an area of 150 meters. What would be the total watts for that area?
6,000 watts.
Say 6,000 watts. Anybody disagree with that? Or anybody agree with that?
I agree with that. 6,000.
All right. 6,000. All right. If I have an area then of 279.5 watts, what will be my total watts for the area of the house?
So 279.
8.5.
That would be 8,000.
8,000. So you want, Mr. Grunt or anyone, you want to explain how you came up with that 8,000?
5,000 watts for the first 90. For every 90 afterwards, it's 1,000 watts. Every 90 meters and remainder, it's 1,000 watts.
Where do you get that from, Mr. Grant?
I don't know. I don't know the code book. I'm gonna tell you section 8. I gotta look to see exactly where, but yeah.
Yeah, where you get that from?
The code book.
Which code book?
The Canadian code. Code 2000. What is it? 22nd edition. 21st edition. You want the section too?
That's it, man. You gotta tell me. Look what on the screen. It says, look, the screen tell you right there,
Yeah, 8,200 subsection.
So that's what I said. I just asked you one question. I just asked you one question where you get it from. I know, because I had Mr. Turner last night telling me one thing, I had somebody else help me. So I just want to know where you get it from.
I beg your pardon. Yet.
I just need to know. All right, so Mr. Grant said, according to the Canadian Electrical Code, the 25th edition, Section 8, Sub-Rule 200, Subparagraph 8, told him how to calculate the area. That's all I saying, you know. So you jump in the oil and somebody asks you, you got to be able to defend it, Mr. Grant.
Yes, sir.
That's all I saying. So this is a part of actually preparing you to be able to actually interpret, but also speak the language. And speaking where when the fella hear you talk, he can say, well, that fella must be a lawyer. Sub-rule what? A200, or rule A200, sub-rule A. You know, and so you actually going down. It means that you know something about the code book. And to be more specific, you know something about the Canadian Electrical Code book. And to be a little bit more specific, you speaking about the latest code book that the Canadian has put out, the 25th edition. You gents and ladies can see on the exam, that's where the code can ask you to make your reference to, and you actually speaking. And so we will drill you a little bit more, but you will have to actually quote more section from the code when you come to do and look at question number 7, which is a code question. But for section A, what I want you to do and always be able to do is actually give me some information pertaining to when you do the calculation for your area, you indicate where that came from. All right. So that's one of the things. The other thing is that I can do a little drawing, trying to set this screen so we'll be able to see it. And so, have anyone had any difficulties? In interpreting at this point section 8200 and what it's asking of us? Anyone?
My favorite section.
Say again?
That's my favorite section.
That's your favorite? I like that. All right, that's some good stuff. That's your favorite section. All right. So again, for folks who were sitting here last night, if you look in the chat, we would have actually sent some pictures out there in the chat. We would have actually put some pictures out there in the chat. And so I can give you a drawing. And this question 1D that we looked at last night, which is the electrical riser layout. And my recommendation is that you actually draw, this will be one of the first things you do on the exam. You draw your riser, even though you don't label it out. You just draw it and you put it on the side, you put it on a separate sheet of paper by itself. You gotta make sure that you use a ruler. I'm doing it freehand. You must use a ruler when you actually drawing your riser. You don't want a little small drawing or something nice and neat. You also want to make certain that you only draw on one side and you write your name exactly in the top left, write the section number on the top left hand corner. And so you want to do a pretty riser. Again, I've seen some riser diagram drawn where they put the service head. I showed this yesterday. Fella, ladies, we want a little small drawing like this. Hardly see it on a sheet of paper. And they put their service head with the wire sticking up in the air. The reason why the service head is designed the way it is designed is that so when it rains, you don't have water going down into the meter. And normally, like when you take a load or an overhead service, normally for the electrician will actually draw the crinkly lines, and that stops the wire from dropping back down into the meter if they ain't properly connected up, or they ain't connected up when they pull it. That's a look a little better as well. Okay, so I want you to make it a practice of drawing this nice and neat. I will show you from the code book tonight how we came and we determined what size our service mast should be from the code. And the code would have given us some specific size. So Grant, you want to tell me what section of the code we find that? What speaks about the size of a service mass? Or someone, tell me what size my service mass is and where I found it from the code. No, Mr. Store?
Say again?
What section of the code I will find my service mass?
Trying to remember that.
That's important, and you should have that highlighted. Section 6, 102. 112, section 6, 112.
Section 6.
Section 6, 112. Section 6, 112. Section 6, 112. This is extremely important. It read. Everybody have it?
Doesn't it just tell us last night it was like 665 millimeters?
63 millimeters.
Yes, sir.
Yeah, 63. But I want to know. I tell you, I want to know where you find it. How you find it? I just don't want you. I don't want you all to be accountable. I want to say according to the Canadian code. All right. So I want you to highlight that section in the code. Section 6112, support for the attachment of overhead supplies or consumer service conductors. All right. And one of the key things I want you to make note. One of the key things I want you to make note is section 6112, subrule 2. But I'll read subrule 1. A means of attachment shall be provided for all supply or consumer service conductors. 2. The point of attachment of supply or consumer service conductors shall not exceed 9 meters above grade or sidewalk and shall be located such that the clearance of supply conductors at any point above finished grade shall not be less than the following. This is extremely important. Gents and ladies, it's extremely important. They've been specific. From crossing a highway street, lanes and alleys, it should be 5.5 meters. Driveway or residential garage, 4 meters. Across driveway to commercial and industrial premises, 5 meters. And across ground normally accessible to pedestrians only, 3.5 meters. That's extremely important. It's extremely important. I want you to highlight. Subrule 3 says, exposed service conductors that are not higher than window, doors, or porches shall have a clearance of not less than 1 meter from the window, door, or porch. And I like to use the balcony, for example. So some people balcony have their service mass where it go up through, or in some cases, they have it surface mounted on the wall. And so you have a balcony. The code is saying you should have that 1 meter away. So I don't want not easy to touch that. Been specific. Why I'm telling you highlight this here because sometime in oral they may ask you this question. You will never see this here. You never see this here in a single phase. However, this information is extremely good for you when time for you to put your service mass down. When the inspector come and he tell you point your service or put your service over here, you will already know that I understand why he or she is telling me to locate my service there because it's based on these clearance requirements from the code. And that is why that is extremely important. Okay. And so when we turn over, it's been very specific. It says where service masks are used, they shall be of metal and assembled from components suitable for service mass. And how they being clear? The service mass, rigid steel conduit of a minimum normal size of 63 trade size shall be permitted to be used for the purpose of subrule 4, provided that all other requirements of the service are complied. So I'm telling you, the minimum size of my service, well, the size is not minimum size, sorry. The size of my service mast must be the 63 millimeter. That's from the code. 63 millimeter. And so I know I can use 3 number something in a 63 millimeter galvanized conduit. They call it rigid galvanized conduit. Same thing. Write that on conduit. I didn't determine my wire sizes yet. But I know I can have 3 of them. Why I know I can have 3 of them? Because the question tells us that our service, this is 3-wire service. So that's where that 3 come from. Any questions up to that point? Any questions up to that point? Anyone? Okay, good. No questions. All right. Let's also go down to the code, to the section of code where we determine the size ground. The size ground for an AC system. And Mr. Storr, what section we go in? Section 10 what? Section 10.
Section 10. So I can remember this. For the AC. I think
114.
148.
Yeah.
Section 10, 114.
I said that for Mr. Amaleo.
That's what you say? What section we use for our ground? Somebody else, Mr. Storr?
Yeah, I can use some help because I remember that one.
10, 114.
10, 114. Mr. Grant, you want to read that for me, please? Tell me what the heading say there.
Grounding conductor size.
Grounding conductor size, that's it?
Oh, okay. Rule 10, what is?
10.
Subsection 114.
Uh-huh.
Grounding conductor size. See Appendix B. Except as permitted by sub-rule 2, the ground conductor shall be a size not smaller than a number 6 gauge of copper or
6 American wire gauge.
yeah. Thank you, sir.
Right.
And number 4 American wire gauge if it's aluminum.
Right. Okay. Thanks, Mr. G. So the code been specific from section 10-114. Now listen, the size of my ground, if it's copper, needs to be a number 6. And if it's aluminum, it'd be a number 4. So I know the size of my ground here. I only can carry 1 ground. I can carry 1 number 6. And our question normally tells us the type of installation. And I think this question told us our installation was TW. We have 1 number 6 TW. I know we can put that in a 16 millimeter PVC conduit. I'll show you where we find that when we come to size and how much wires we could carry in a pipe, or how much conductors we could carry in a conduit. So 1 number 6 TW and a 16
Mr. Ravi, you could bring the screen down a little bit.
PVC. Okay. You see that? 1 number 6 TW and a 16 millimeter PVC conduit. Why PVC? Because it's extremely important. You can see where our galvanized nipple for our mass, galvanized conductor for our mass. We can use the galvanized nipple coming down through here. And we can use a piece of PVC going across. That's why it's so important for you to indicate that. This part of the question costs, it's a total of 15 points. So you want to make certain you get this. But what I want is for you to get familiar with section 10116, where you determine your ground size, that's where it came from. So you can find that. You ain't gonna hurt your head, that can be standard. And also you know where to go to section 6112 to determine the size of your mass. That's where we came from. Any questions? Okay. No questions. I'm taking this casually. So let's say, and this is how I want you, hopefully folks, you can see this on the board. I can do a little drawing, a little square up here. Section 1C. As I told you, find my area. Remember we said when we can find our area, we can take our centimeter rule and we can measure our inside dimensions. Measure our inside dimension. I want you to make a practice of setting this up. Just like this. Area equal to length times the breadth over 2 times 2. When you make that a practice. Also, I want you to put this up here, section 8-200. That's the rule. 8. You put that there. A.
Hey, Mr. Darwell.
Yes, sir.
You cannot see that.
You can't see that, right?
No, sir.
All right. What about now? No? See it now? Huh?
If you could go against the dot more than so that.
Yeah.
Right up.
All right. So we have section 8-200, because the code tell us, section 8-200, the minimum capacity of the consumer service freed up is based on the grade of item A or B. So I'm labeling this here. Also, I want you to put on the side of here, section 8-110, because this is what tell us to deal with the area. That is why I'm putting that here. So I want you to watch me now as I put these little rules in place, because this is how I want you to now get in a practice of actually setting up. So on one sheet of paper, you put your name, section on the left-hand corner, and you put these rules. You set this up here. You also, from the plan that be given to you, where you get these measurements, you can see 2 centimeters equal 1 meter. I want you to put that there as well. And then when you come now to set your calculations up, and the code tell us on page 95 or 96, the minimum capacity of the consumer service wire is based on the grade of item A or B. And I know I can address item B first. Watch me now, item B first. And so I'm coming here. I'm saying on my plan, on my sheet of paper, section 8-200 B. meters squared or more, 24,400 watts, or 80 meters squared or less.
Mr. Darwell,
Right?
are you telling us to do this on the exam, or this is just so that we
On the
learn
exam.
it?
On the exam, so on the exam,
You don't think this is a waste of time?
all right, so I can read the question to you. No, I don't think it's a waste of time. This calculation value, if you look at it, the calculation value 15 points. 15 points. Where you get this information from? That's the question. When I asked you, said, determine the minimum capacity of the consumer service as specified by the what? By the code.
Playing good.
By the
Yeah,
code.
yeah, but you
So-
writing all this stuff,
But
and I think you taking time from doing the question Because you still have to go to the code to find these stuff. So why are you writing it down?
How I know you have the code inside there, even though I know you're loud? It says
That's
I'm only reading what instruction tell me.
but I if I have the code in front of me
Right?
and I get the answers from the code, why do I have to write this stuff?
Couple reasons. So let's say for example, let's say for example, I don't see the rule numbers, none of these rule numbers. And you come up with a value, and your value is off. For whatever reason, your value is off. Should I just mark you wrong? I shouldn't give you a point.
No, I'm not saying okay, I think I should write like say if I got my answer, I should write A200A.
Uh-huh.
That's where I'm referencing from. But that's it. You're writing all this 80 meters squared or
But that's what the code says. The code says the minimum capacity of consumer service wire is based on the grade of item A or B.
yeah. So if I just write the code number, shouldn't that say enough instead of writing 80 meters squared or more? If I just write the code, it's the code reference A200B.
Okay,
Then
so
just go to A200B and you would see what that say instead of writing 80 meters squared or more.
I like
I
that.
think I think that's wasting time to me. So,
Okay.
but I'm wondering if it's necessary, because if it's necessary, then I would do it your way.
Let me tell you why it is necessary. Section A200B, right, gives you two options. You see that?
Yeah. So if my area is
Right,
over
so-
80 meters squared, then I'd use one of them. If it's not, then I'd use the other one. So just follow the code that I put, the code that I write.
So
I
let's
don't
say-
think
So let's say hypothetically, you get your area wrong. You put a decimal someplace. You get it wrong.
hmm
Hypothetically, you get
Mhm.
it wrong. Even though your calculation, the values that you gave is only one decimal you put in place wrong. When we sit down to analyze, I can look, I can say, listen, Ms. Jason, why she done indicate section A200B has two options. She showed me that. She also showed me that, listen, the code told us you must select the greater of item A or B. And you showed me this here. Yes, my final answer to say the minimum capacity of the consumer service feeder is based on section A200, let's say in this case A. I know that's gonna be your answer, but the way how you lay it out, and I'm offering for this calculation, I'm offering 15 points. If you just give me numbers without no rule numbers, for me, I can't just, and even though the question, and this is the other part I want you to see, the question says, determine the minimum capacity of a consumer service wire as specified by the code. That's number one, as specified by the code. But let's go a little further. When you go up front, when you look at the other consideration to the code, it says, consider you have the task of planning the complete electrical installation, which will be suitable for the submission to the appropriate licensing authority in accordance with the 25th edition, right? 25th edition. You don't tell me this. I could almost use the 24th edition and get the same interpretation. However, if I try to use, for example, the 23rd edition, the 23rd edition will give me either 100 amps, if it's 80 meters or more, or if it's less than 80, it'll give me 60 amps. That have changed. But you specifying these sections of the code shows me, literally shows me that yes, you understand the interpretation. Secondly, when you go, and believe it or not, this can be the first exam, will be the first piece of document that will land in the ministry to make up your file. This is what we'll send down there. And this will be on your file. So when they say, oh, they have Ms. Tracy came to do her oral. All right, fine, she passed her theory. You should just question her more on section 8 or get some question from her from section 8. I think that is how they sometimes select what questions they ask individuals in reference with the oral. And so my thing, and I said this to Mr. Grant, I think earlier, you tell me how if I have a, for example, Ms. Jason, and you answer this, I have a area of 91.5 meters squared. What is the total watts? Tracy?
You have
Have
an
an area?
area of 91.5,
Right, meters squared. What is the total watts?
5,000 plus 1,000,
Okay,
6,000.
6,000. Okay. Well, where you got that from?
I'd write the code next to it.
With the and that's all I do is writing the code next to it.
But you're not writing the code.
Okay.
You're not writing just
Okay.
the code reference. You're writing what the code is actually saying.
Okay, so let's use it from. I can ask you that question. You answer me from an oral perspective. I have a house area that is 90 meters squared per 5. What is the total watts? You said 6,000, right?
Yes,
Where you got that from?
I got that from section A200A
Uh-huh.
of the Canadian Code,
That's it?
25th edition.
Oh, okay, 25th. Because the Canadian Code been around 90 years.
Yes.
And so some things you gotta be a little specific to. And
Okay.
and that is why, and you can see as we bounce back and forth, my thing, I don't want no reason. When the examiner look at your answer and say, I got 15 points to give, I want him to have a struggle.
Okay.
I want him to have a struggle, the way how you lay it out.
Okay, one more question. I understand. One more question. How much time do you recommend we take on section A, this whole section A part?
Okay, that's a good question. So we have 3.5 hours. If I spend 15 minutes, on each of the questions, each of the 5 questions in section B, right? Each of the 5 questions on section B, that give me an hour and 15 minutes, right? Got it down, 15 minutes. Let's put it up a little more. Let's say we spend 20 minutes. All right, on each of the 5 questions inside section B. And give me an hour and how much? Hour and a half?
Hour and 40 minutes.
40 minutes. Okay, we got an hour and 40 minutes. The exam is 3.5 hours. All right, 3.5 hours. So I have 2 hours and 230 minutes left to do section A. And so my thing is that when you look at section A, and section A is divided into 1 of 4 sections, Ms. Tracy, for this calculation and this riser. I ain't expecting you to spend no more than 20 minutes on this. 2 of them. You coming into the exam, you reading all the question paper, and you drawing your riser, you putting your arrows in, but you ain't putting nothing in other than listen, you just found from the code, the ground size is gonna be a number 6, TW75, and a 16mm PVC. You found also that you could use 3, because the question told you 3 number something. But you know the size is a 63mm and it's galvanized. You drawing that up, nice and neat, pretty, and then you resting it on your side. That should take you a good, I give you 20 minutes, a good 5 minutes to do that drawing. And then you come in and you can do this calculation here, 15 minutes. And you can take your time, open your plan, pick your centimeter ruler. You can get your area, like when you lay it out, putting these rules up here, and then you can come with the calculations. I want no reason, absolutely no reason for you to lose points in this section, because section A is so crucial. It's so crucial. If you don't get the calculation right, I mean, your rise could be wrong, your distribution board size could be wrong, your disconnect could be wrong, and you ought to start all over again. You good? I'm being picky with this. I want this like this. I want you to lay this out and give me this information. When this person look at, when the examiner look at the way how you have this laid out, and if you practice this now, all it means is you actually just come in, doing your measure and putting figures in. So here we go. Area total watts. Area total could lay it out here. You could say, let's say hypothetically, we measure on the inside and we come up with 30. We got the width, we come up with 20. So we come over here, we say 30 over 2 times 20 over 2 give us 600 over 4 equal to hundreds, put it here, 150 meters squared. And all I did is I divide this by 90 and give us, 2 nines are 18, so we know 90 goes into that one with a remainder, so I got 6,000. So my area total watts is 6,000 watts. Anybody have any question with that? How we found that? Okay, so I go pick up the speed. So let's grab one, and I go put some loads in on top of my head. We have to do the calculation. So let's say we have, for somebody, Mr. Tracy, you give me some values. I'm doing the house calculation. You give me some values. Let's say we have AC.
How AC?
Yeah.
You want the
I-
total AC?
Yeah, you no, give me the individual ACs. I want you to practice an individual and you'll see where this come back. So we have
Okay.
individual AC, the first one, and AC and living room.
1,500 watts.
Okay, so Mr. Tracy, so now we just gotta talk.
Um,
Why you 1,500 watts is what?
What? Say again?
1,500 watts is what?
What do you mean is what?
You said you have AC in the living room and it's 1,500 watts, 1,500 watts, right? So
Yeah.
you say I automatically just go and put that in my total watts area?
I don't know what you're asking.
You told me we have an air condition. You look at your question paper, right? And you see you have air condition. You told me air condition was 1,500 watts,
Yes.
right? I'm actually explain what I was doing with that 1,000 watts.
Oh,
And,
You
and
could,
then why? And then why?
1,500 watts, you add that in at 100%.
Why?
That's what the code say.
Which code you read from, ma'am? All right, so that's important. So I want you to look at section 8200. See, I'm arming you to the T. And on the screen, you'll see when I talk about these steps. And I want you to get familiar with following these steps. I'll send this presentation, but you look at section 8200, the code been very specific. After I found my area, it says any electrical space heating loads provided for with a demand factor as permitted in section 62, plus any air conditioning load, and they talk about if I have interlocking device, any air conditioning load with a demand factor of 100% subjected to rule 81064. And so why I want you to have this right down to the T, Ms. Tristan? Because the code tell you, first, tell me in this residential house, do I have space heating and do I have air conditioning? And this is where now you can start doing your question quickly because you don't look and you say, I don't have no space heating. I don't have no space heating. So I could go right in and add my air conditioning at 100%. I want you to see that. However, when we transition over to question 4, you can see where you will have to compare. If I have space heating and air conditioning, how I determine which one is the greater. You follow me?
Yes.
Right. And so that's why I want you to get a feel of the flow, how the code tell you, you move it step by step, but use those same steps. As section 8 tell you. So from the house calculation, we look, we see, we don't have a space heating, so I know I'll use all of my air conditions, Ms. Tristan, at 100%. I want you to be able to talk this. So when you go down to building control and you tell them this is why this riser is wrong, you could say it verbatim out of the code. Or you could say, yes, that's fine. or if they ask you to explain how you did your calculations, you could say it step by step. Or you can say, I can refer you to section A200. This is what it's saying in section A200. Or when you get in an argument with Mr. Roll who come down there and telling you his riser is correct, and he know he's supposed to be using a 4 odd, and you say, no, Mr. Roll, you oversizing our service, and this is the reason why. I want you to be able to go there and show it, because a lot of times, person will submit a riser and only find that, hey, it's been objected, but no one tell them. And so I would want, if you come upon a situation, this for everyone, you come upon a situation like that, you will be able to explain it. Or if you have to defend out in the field, you'll be able to defend it. So in this case, we don't have no electrical range, no electrical space heating. So I can put all my AC value in at 100%, but I want you to see where it came from. But I want you to remember that section, highlight that, because question 4 can come at you with that. All right, so we have AC load for the living room, 1,500 watts. Do we have say again?
We using the numbers from the mock exam or just any number?
Any number. This your house.
Oh, okay. 1,000. How many ACs we have?
3.
1,000
Where you putting it?
underneath.
I mean, where you putting this AC can be located where?
Bedroom 1.
Bedroom 1. Okay, that's important. That's important. Why I'm asking this, gents and lady, to Ms. Tracy, because on your distribution board, you can say AC in living room. When they talk about the details, and this is when we come to the distribution board, in that area for detail, you'll say AC in living room. That's the detail. AC in bedroom number 1. AC, and what the next AC is, ma'am?
AC bedroom number 2 is 1,000 watts.
Okay. You have an next AC? Because it's a 3-bed, right?
3-bed. Okay. The next bed, my AC bedroom number 3
Okay.
is 1,200 watts.
Good. So we put the air conditioning values in at 100% because we don't have a space heating, Ms. Tracy. That's all we said there. What else you have in this house?
Let me see. I want a washing machine.
So I want you to look at, all right, so let's go. Okay, let's go. You want a washing machine? But I'm preparing you to pass this exam, so I got to program you. I want you to look at section A200. Look at section A200. Remember the steps? Look at section A200.
Yeah.
All right, I want you to follow them. Do you have an electrical range in this house?
No.
No, so I can put range and I can put 0. Range and I put 0. Do you have any tankless water heater? Water heater for swimming pool, hot tub, or spa?
Yeah, I want a hot tub
You want also we have okay.
and a spa.
Water heater for
Don't want to
you want a
Might as well.
for hot
Cozy to it.
tub and a water heater for a spa. What the value is?
Let me see. 6,000 watts.
For each one of them?
Oh no, 3,000 for each.
Okay, 3,000 for that water heater for the tub and 3,000 for the spa. What the code tell us? How do we address their wattage? What the code tell us?
Any electric water heater, tankless water heater, swimming at 100%. Demand factor of 100%.
Okay, so we put them in as 100%. Good. We can get out of washing machine. Very expensive things. That's the boss.
Mr. Double, when you finish writing, you can move the camera more to your left. Yeah, you probably can bring it down a little bit too, so we can see the rest of that writing. Yeah.
Okay. All right, Mr. Tracy. What next? I'm on
Okay,
section 8, I'm
electrical,
on section 8200.
electrical vehicle supply.
Yeah, you have what kind of car you rolling out? Tesla, what?
Must be a Tesla, I know.
All right, so you have an electrical vehicle equipment. Okay.
Hey, that no BMW let you do, you know.
Electrical vehicle equipment. What's the value?
8,000 watts.
Yeah, that's a boss. Tell you what. Good stuff. And how the codes have you deal with them?
Demand factor of 100%.
Okay. Next.
Okay. So
Section 81,
next is,
follow the steps
okay, following the steps is any loads, any other loads
provided for.
that have a rating in excess of 1,500 watts.
Okay, so tell me these other loads you have inside here. You
I
said
have
something,
a
washing
washer.
machine, yeah. So you gotta have a washer and a dryer, right?
Mm-hmm.
All right, so let's go. We have a washing machine with the value.
2,000 watts.
Okay. And you have a dryer. What is the dryer?
5,000 watts.
All right, anything else?
That's it.
Your water heater, right?
A water pump or a water
Oh,
heater?
I have a water heater.
All right.
Yeah, water heater. A regular water heater.
Okay, so that's water heater for cleaning. What's the value?
3,000 watts.
3,000.
I know.
Mm-hmm. Anything else?
That's it.
That's it? Okay. All right. So, so that's the interpretation. The code tell me how much water was the dryer? How much was the dryer? The dryer, clothes dryer is 5,000. Water is 3,000. So the code tell me when I don't have an electrical range and I have other loads, I must deal with those other loads in a particular way. Those other loads are washing machine that is 2,000, the clothes dryer that is 5,000 watts, and the water heater for cleaning that is 3,000 watts. And so the interpretation from the code, and this is what the code say, when I don't have electrical range and I have other loads, this is how to deal with those other loads. Putting it on the screen. It says, if electrical range was added in step 4, add 25% of the other loads, demand combined loads. If electrical range was not added in step 4, add the first 6,000 of the other equipment demand combined loads and 100%, add 100%, then 25% of the remainder. That's all it's saying. When you look at your question on exam, and you see now there, listen, I don't have an electrical range and I have other loads. Once those other loads exceed 1,500 watts, add them up. Add them up. The first 6,000 you use at 100%, and then 25% of the remainder. So when I add up the Tristan other loads, which is 3, these combined loads, I add in 2,000 plus 5,000 to 7 plus 3,000, that give me 10,000. And so my other load total watts is equal to 10,000 watts. The code tell me the first 6,000 I must use at 100% and the remainder at 25. So when I take 6,000 from 10,000, that leave me with 4,000, and then I find 25% of that 4,000. Everybody follow that? Everyone follow that? Stacey, you got me on that?
Yes, yes, I follow.
You got me? All right. So 25% of 4,000 is what? 1,000. So I find 25, I can be a little low, 25% of 4,000 is equal to, put that someplace. I can put, hopefully you can see this on the board. So all I'm doing here, I can say other loads. Is equal to 10,000 watts minus 6,000 leaves 40, and this 6,000 is at 100% plus 25% of the 4,000, which is equal to 1,000. So my total here, and I put in bracket is 6,000. My total load for my other, total water for my other loads is 7,000 watts. So what I want you to put down here in this column, other load total watts is equal to 7,000 watts. Other load. All right, Mr. Easton. Now we go ahead and let's add up. My area total watts, 6,000. My 3-year condition loads, first one is 15. Second one is 1,000. Third one is 1,000. The fourth one is 1,200. Then I add up my tankless water heater. No, sorry, my water heater for my tub. My water heater for my spa. So that's 3,000 plus 3,000 plus my electrical vehicle system, which was 8,000, and then my other load, which was 7,000, that gave me 31,700 watts. All over 120 times 2, it gives me 132.083. Capacity of how much? 132.083 amps. Tracy, are we straight?
Yes.
All right. Anybody didn't get that? 132.083. Anyone did not get this value?
Not right now.
You open the camera and look for my toy, please.
Yes, sir.
Mr. Darwin,
Yes, sir.
you get 28,700?
No, I have 32,083, according to Mr. Roll calculation.
No, I talk about when you do the total, when you add up all.
Sorry, when I add up all, I have 31,700.
What?
31,700.
I doing something wrong.
Yeah. Yeah. Check your numbers. Check what your area total watts was. AC. AC in the bedroom. Yeah. How much water heaters you have there? And that is why I say it's so important for you to follow the steps straight from section 8200. Extremely important. All right. So, Mr. Jason, I want you to tell me now. So you do your calculations, and when you do your calculations, you can leave me with this value right here, 133.082 amps. That's what you're telling me?
Well, that's not the answer.
Okay, so tell me how you would tell me what the answer is. After you do all this calculation here. And then you tell me how and why. That's important. I want
Okay,
you
let me see.
Yes.
Let me see what the question asks.
Question D says, determine the minimum capacity of the consumer service wire as specified by the code for the installation as planned in Part A. Determine the minimum opacity is the question.
Okay, the minimum opacity of the wire, you have to go to table 2.
The exterior. What exterior is that?
But that'll be 150 amp.
Let's see table 2.
Here's the main, this section 8, main, this section, I think that's a regular house.
132.
You
Yes,
go on a
we
question
get
for you. I got a question. Why you start here because Tuesday is a given. Some folks don't. So I have to start here to come over there. I go on there. Yeah. What you say, Mr. Easton? Talk to me, ma'am.
You have to go to table 2.
Okay, we go to table number 2.
Oh yeah, I'm trying to pull it up.
So, Mr. Darwin,
Yes, sir.
that's 150 amp. 2 watt.
2 watt. Okay, so let's go. You pull up the code.
Okay, table 2, column
60,
the
60
60
Celsius.
degree, the 60-degree column, whatever column it is.
Right. Okay.
And then we have 132
130.
32 amps.
130. This is what we calculated, eh?
Yeah, that's what we calculate. So
All right.
the answer to the question, the minimum opacity of the wire
Right.
is 145 amps, and that's a
145 amps.
two-odd wire.
That's a 2 watt wire. So that's extremely important. So let me show you why this is so important. All right. So you did your calculations and you came up with 132. You see that? You came up with 132.08. That's based on the calculation that you give. But now you have to go to section table number 2. What sent us to table number 2? How you got the table number 2? Mr. Tracy?
Because table number 2 is where you
How you-
find how I get there.
Yeah, how you got there?
I don't know how to answer that.
How you get there?
I don't know.
What rule?
The rule said you over there.
I'm trying to find now.
I don't know how to answer that. The rules send me there.
Yeah, so I can show you from the rule. You see, I just don't want to tell you go to table number 2 and you tell him, Mr. Dow will tell you go to table number 2. So let's find that rule that tell us to go there and why we going under column number 2. I'm being picky.
What rule? What the
I can
rule
find
is?
a rule for you right now. I can tell you the rule on the table that sent us there. Unlock this table, section number 4. Here we go. I'm telling you right now. Okay, I can tell you right now, man. Give me a minute. So if you go to section 4004.
Section 4. Opacity of wires and cables.
Yes, ma'am. I read. Highlight it if you ain't got it. Section 4004. See, I ain't giving you this just to say go out there and you pass this and then you gotta defend it. You gotta be able to defend it. Everything you do, you gotta be able to defend it. It reads, the maximum current that a copper conductor, you see that? Copper conductor, that's number 1. Why are you on the table number 2? Because table number 2 speaks about copper conductors, eh?
Yeah.
That's the first one. Copper conductor of a given size and installation is permitted to carry shall be as follows. For a single conductor or a single conductor metal sheeting or armor cable in a free air run with a cable spacing not less than 100% of the largest cable dimension as specified in table 1. So they're telling you if you're only carrying one, deal with table number 1. B, 1, 2, or 3 conductors in a run or a raceway, or 2 or 3 conductor cable except as indicated in sub-rule 1D as specified in table number what? Miss Tracy, table number 2.
2.
All right. And so that's the reason why we got over the table number 2. Mr. Darwin ain't send you over there, the code send you over there. That's extremely, extremely important. Extremely important. We understand where we go, why we go, and when we're dealing with table number, well, with saying how and where we go, where we went. So table number 2 told you, fine. Yes, sir. That's the only one we use with single phase. Table number 2, well, you can maybe get a little taste of table number 6 as well. When we talking about, because remember that only spoke about 2 or 3, right? We can get where, when I go on across here. So the question was, Mr. Darwin, what other table we can have to deal with? What other table we have to deal with? And I said to Mr. Ingram, when I'm moving, when I go on from my disconnect switch over to my panel, I carry 3 number, in this case, 2 on and 1 number 6 ground. And so I can't use the sizing from table number 2. I got to go ahead and find out the next table. That'll be table number 6. That's the one I said, we'll spend time. I'll show you how we get there. But I just wanted to show you how we actually now come up with this value that we're speaking about. So Ms. Tristan House service is 122.083 amps. When we went to table number 2, we came up with 150 amps. What's the amperage we came up with? Or which wire size? 2 watt?
2 watt, 145 amps.
145 amps. So we're using a 2 watt, 145 amps. That's extremely important. That's extremely important. You will see, and I will show you why this is extremely important, because the lugs in these panels is only rated for 125 amps. We talked about this last evening. So, but 2 things, and straight for ease of comfort, I ain't gonna give you these big figures for a single phase. I ain't give you them big figures. But if you get those big figures, I can show you how you actually address it, because you have to be armed to address it. And so, just hypothetically, we have 3 number 2 odd, 3 number 2 odd, and the question will tell us the type of installation. In this case, it's TW. So we have 3 2 odd. You can write 2 odd as 2 zeros or 2 slash, and a 36 and a 63 millimeter galvanized conduit. That is what we just found when we went to table number 2, so we could put this cable in the inside here. Finish that off, and it's TW. That's important. That's TW. Any question at that point?
Okay. Yeah, Mr. Davos, one question. When we did our calculations, we got the amperage was 132.083. Then we went to the table to find the wire size.
The closest number but bigger than 132.083. So
Right.
he went up the column, he came out 140. And he moved across to the left and he saw it as a 2 odd.
All right, I got that piece. What I want to know is with the 145, yeah, that's 145. Do I put that down as well, or
what the question? And this is the same thing Miss Tracy asked. This is what the question say. Determine the minimum ampacity of what? Of the consumer service wire. So the minimum ampacity of the consumer service wire is how much? 140 amps?
Right, 145, right? Yeah.
Right, that's the minimum ampacity.
Yeah.
You got that?
I got that.
Where that came from? Table number 2.
Yes,
but
sir.
tell Ms. Tracy that is in accordance with the greater, Ms. Tracy, that is in accordance with the greater of section 8200 A and B.
So, Mr. Darwin.
Yes, sir.
Okay, we know they don't have 140 amp breaker, 45 amp breaker. So if I put 150 on my paper, would that be correct?
You dead wrong.
How?
You say they don't have, who tell you they don't have 100 and...
I never seen that. Okay,
all right. So Mr. Turner, you ain't never seen that. But we ain't finished doing the rating, because I only gonna use 80%. But to answer question one at a time, question asks you determine the minimum ampacity of the consumer service feeder. Answer that question. You just determine that to be 140. I ain't asked you nothing over here.
Okay.
I ain't asked you none of that. I can get to that.
Well, I just write down 150 amp.
Yes, according to section 8, according to the grader of section 8200A and B. You good?
All right, sir.
You good with that?
So erase that and put 145.
Erase what?
I say now for the breaker size, I put 150.
What breaker we talking about? I ain't talking that no breaker yet.
Okay then. All right.
I want to jump no gun and then you tell him I cost you to jump. Not me, sir. I ain't reached no breaker yet.
Sorry, sir.
I just did 1C, did my calculation, and determined the minimum capacity of my consumer service feeder is 145 amps, or a 2-watt. So all I did, I told you, this is the ground size, according to section 10-110, and I found my my service mass, which was 63 millimeters, according to section 6104. That's all. That's all I done so far. Any questions up to this point? No questions. Okay. So, Mr. Easton, so I want you to take a look at the area. That's why it's so important. Why it's so important, just put this here. So you write this down in a half a minute, that there. You got that locked in, section 8200B. And you put this here. It makes it easy, especially if section 8200A is the grader. You just come and you just indicate that. You already have that in place. That helps to save time again. That's why I want you to put that there. Good? Any questions? All right. Everyone should have a question 4 paper in the front of them. Everyone should have a question 4 paper in the front of them. Any question 4 paper, anyone? Anyone have a question 4? All right. Who don't have a question 4 paper? One should be in the portal. Who don't have a question 4 paper? Right, I only have one person saying one. So let me see if I can find your question 4. You will get a working sheet of question 4. We don't do all of them. Yes, 2 types of. We get 2 types of numbers. Okay. Yeah. No. I use it random. I want random, and that's for a reason. I just want to get the feel that you get it, interpretation of it. That's my. How many questions do you have to answer? You have to answer 5 from section B to get 100, and all from section A. All right, Ms. Tracy, you ready?
Ready for what?
Pull out question 4.
Okay.
Pull out a question 4. Everybody, please, I want everyone to have a question 4 in the front of them.
Yeah.
I want everybody to get ready to have a conversation with me on question 4. I need you to have your pencil. I need you to have your pencil or your pen. When we start to dissect question 4. All right, so you should have a question 4 reading. I can read mine and tell me how different yours is from mine, but it's technically the same. You should have your code on the side of you as well. When you have your code on the side of you as well. Section 8200 on the side of you as well. Tell me when I could get started. So turn I could go.
Yes, sir.
All right. It says a duplex resident consists of 2 units. A and B has the following details. Has the following details. Has the following details. And they tell you unit identification, area, space heating, air condition, range, water heater for jacuzzi, tankless water heater, clothes dryer, water heater for general use. I want us to collectively, let's go through the 7 steps for us to determine the feeder to each unit. Just like how we did with the house, I want us to go through those same 7 steps. Before we get started, it says, right to the bottom, it says, in addition, there is a house load of X amount of watts. I want you to put equal. Whatever the house load, put equal. And put P is equal to V times I. And put I is equal to P over V. And you put equal. And whatever that value is, you put the value on top. In this case, mine is 18,000. And I want you to go right down to the bottom. It says, if the source for all loads is single phase, 3 wire, 120/240, calculate the minimum capacity of the following. The feeder to each unit, the feeder to the house. You are in the process of calculating the feeder to the house. So you put whatever that value is, the total watts, over 120 times 2, or I give you 240, and tell me what your minimum capacity is to the feeder to the house. 75 amps, so it means Mr. Roll total watts was 18,000. Stacy, what's your total watts, or what is the minimum capacity to the feeder to your house?
53.3 amps.
So that's 2 points already. Mr. Trainer, what is the minimum capacity to feed it to the house?
You say you use 18.5. I use what I see on my paper. But
So I
anyway.
tell you, no, you ain't even listening. I tell you, use what's on your paper.
Yeah, I get 68.75.
So that's fine. That's all right. All right, I happy with that. Mr. Store, what you got?
You talking about for the amperage?
What's the total watts? And then, yeah, what you got for the amperage?
Total watt was 1800, so 75 amps.
Okay. Mr. Grant, what you came up with?
Same thing. 35 watts. Means amps. Sorry.
Okay. Mr. Thompson, what would you, sir? Mr. Thompson. Mr. Joseph.
I have 18,000 watts, so it's the same thing what they have, 75.
Okay. Mr. Lewis.
Mine was 16.5 kV. So my total amps was 68.75.
Okay, great. Okay, Mr. Green. Mr. Green.
Mine was 25 ohms.
75 is 18. Okay, Mr. Colley.
I think 53.
How much you got?
I think 53.3.
I got 75 ohms.
Green got 75, Collie, you got 53.3. Okay. All right, that's fine. That's important. We can, that's fine. I just want to know that you got the understanding how we calculate that. That's very quickly. That's an easy 2 points. Now, let's go in. So you just found the feeder to the house. The question I asked you, what is the minimum capacity to the feeder? All you say the minimum capacity to feeder to the house is 75, 53.3 amps, whatever that answer is. Now you want to find the minimum capacity to each of the units. Just like how we did the calculations for the single dwelling, we can do the calculation individually for this single dwelling. And so right on the side, I want you to get in the practice of doing this, please. In unit A, what is your area total? Somebody. So give me the meter squared. Area meter squared.
Anyone have questions?
And any one of the questions. I just want you to the question in the front of you, the one that you have in front of you.
Oh, mine is 287 for apartment A, and
So
apartment B is 207.
Okay, so what is your total watts? And tell me how you got it, one at a time. If you have an area of 287 watts, tell me 287 meters squared.
So you want me to give you the entire watts for the entire building or just for the area?
Just for the area.
So
Just
firstly,
for the area.
so for the first building, you divide the 287 by 90.
Also, and Jen, I want you to listen. I want you to listen. So you want what he did at 287. I want you to put it on the side of that 287 for divide by 90.
You get three. After you divide it, you get 3.18 and some change. So the
3.18.
so the first 90 would be automatically be your 6,000 watts.
The first 90 be 5,000?
5,000 watts.
We reading from section 8200, you know. That's where I get the value from.
5,000 watts.
Right.
Number A first. And then any remaining watts would be 1,000 after, even if the excessive. There you go, excessive.
In excess of.
Yes. So that would equal to 6 plus another 3,000.
What's 6? I thought it was 5 plus another
5 plus another 3,000. My apologies.
Okay, good. All right, so let me do a little clarity there. So and that was Mr. Tucson or Mr. Joseph?
Joseph.
Mr. Joseph. Okay, Mr. Joseph. So this what Mr. Joseph did. All he did is he divided 287 by 90. He came up with 3.11 something. And so this is how I want you all very quickly. When you divide that and you come up with 3 point something or 4 point something, you know the first 90 is 5,000. And because I have a 3, it means I have 2 left. And so each one of that 2, so I got 1, and I have another 1,000, and a portion is 1,000. That's how we got that 8,000. We ain't have time to go doing that calculation, all of that. No, we got to move swiftly.
Mr. Darwin.
Yes, sir.
So we add the 245 together, which will give us 90.
How you get there? I hear this again. How you get there?
Listen.
Be on section 8200. Section 8200. Oh. You don't want to turn the law. You don't want to turn the law again.
Man, listen. I say I go to the duplex page, right? And I fall in that and I see it 245. So I said, okay, they add up to 245, which is 90.
You saw a duplex or you saw an apartment? What that say?
Apartment. I see
But how
apartment.
you get there? But how you get there?
I have a question.
Yes, ma'am.
Why are we using section 8200A?
Okay, that's a good question. Okay, so let me help clarify this for
Yeah, because I jumped the gun just now.
I mean, section 1.
Okay, so let's look at section 8203. And then I have a question for Miss Tristan. Section 8202 first. We start with that. It says the calculated load for the consumer service or feeder conductor supplying 2 or more dwelling units, row houses, shall be based on A, the calculated load in the dwelling unit as determined in accordance with sub-rule 1, right? Sub-rule 1, excluding any electrical space heating load and any air conditioning load with the application of the demand factors to the calculated load as required by the rule in section 8202. A, all right? So my first question to you, Ms. Tristan.
Hold on, what you just read? Which rule were you reading?
Section 8200. But I have the screen up. Do you have your screen?
8200.
Section 8200, sub-rule 2.
Okay.
Row houses. We talk about row houses. So let me do this. So Miss Tristan, we are not dealing with apartment, right? You agree?
Well, I don't know.
That's what I'm telling you. We ain't dealing with
So
apartment.
the question would say apartments.
Yeah, it would say apartment. This ain't saying apartment. It's saying duplex resident. And
A
then
duplex resident is not like an apartment?
no, ma'am. That's a Bahamian myth.
Why all this time I thinking that's a
Yeah,
apartment
the local
duplex.
terminology.
That's your local terminology. That's right.
So a duplex residence is not
Just two
similar.
separate houses.
Is not similar to an apartment.
No, ma'am. Apartment you will find. Apartment complex you normally find, in some cases, depending on the size of a common heating. In some cases, like for your water heater, you'll find a common, in some cases, air conditioner. In some cases, you'll find a common, like I used the one, the swimming pool. You'll also find common lighting.
For an apartment.
An apartment complex, yes. Think about an apartment complex. What
So-
we call apartments is row housing.
Okay, hold on.
Row housing.
So Mr. Darwin,
Yes, sir.
so we using section 8200 to do the duplex.
Yes, sir.
So what we call
All-
apartments here is row housing.
Yes, ma'am.
All this time I thinking in the duplex.
That's why
Is
you here
under-
tonight. That's why you here, sir.
So apartments and similar buildings. What is that?
So you might have, so that's, I used an example of. for the folks
Office
in
complex or
Freeport,
something.
Apartment complex. No, office is different.
Okay.
Office is totally different. You'll see that from table number 15. So apartment complex, let's use, let me find a good, for Nassau, I give it, I mean, for in Freeport, I give an example opposite the Independence Mall. You have a big high-rise apartment complex. You have some
Yeah, then you
apartment
have-
complex, right? You have some apartment
Castle
complex.
Fort
that has-
and places like that.
Right, that has a common elevator. Let's use downtown Nassau. So if you go down through the corner opposite, or through Sassoon House corner that you're leading to go to Bay Street, it's a big set of pink apartment complex there. Let me see if I give you something more in a common area. You drive out east, you have a lot of two-story apartment. You got 5 upstairs, 5 downstairs, right? However, the water supply in some cases, depending on how it's constructed, there is one water supply. You could have row houses that could have, and we just changed our law and reference with you can't have a building if you don't have government water connected. Back in the day, you was able to get away with that. Back in the day. So you could have row houses. You could have row houses that have individual meters. You could have apartment complex in some cases that have individual meters. But one of the key things that stand out for apartment complex, once there is apartment complex, they normally will have a fire pump. So you will have a meter that is unique to each of the units, but you will have a meter that is responsible for your fire pump, exterior lighting, etc., stuff like that. And then normally you have an apartment complex. They normally have like one general gas if they use them for cooking, that type of stuff. And so that's part of the stuff that distinguish the difference between row housing and apartment complex. Hopefully that cleared it up, Miss.
Yeah, it
Tracy.
did. I understand.
Yeah.
So Dava, on
Yes,
on
sir.
French Charles, on the side of the bank, that's an apartment complex then.
That's correct.
All right.
When you say by Commonwealth?
Yeah, right by Commonwealth on French Charles.
Yes, sir. Yeah. The one of the things with the apartment complex, the parking is unique, and they always got to have that play area, specific play area for your apartment complex or play space. Row housing, like I said, but I only got this little small yard. Everybody live and play there. That's how it normally is. So that was one of the big questions we had last evening, and clarifying that, Madam Thurston. Okay. So I'm scrolling right down, going right back. So I'm following all of the requirements, and this is why I'm saying it's so important for you to understand section A200, because when it comes to answering question 4, you done it. And so all is a means of repeat. One other difference too, Miss Jason, the area in some apartment complex could be smaller. So when you look at section 8202, it says the first 45 is 3,500 meters. And then the second 45 is 1,500. And so that comes fall right in line with our first 95,000. And then the portion thereof. And it also speaks about the portion thereof if we go over that as well.
Okay.
All right? Good. Mr. Trainer, that clears it up?
So in this, we wouldn't be using 8202 then, at no point.
8202, no, sir. You won't use section 8202. You'll use section 8200.
Okay. Why all the time I was thinking, that's how come I start calculating the same if you add the 245 together, because the duplexes are apartment.
The funniest thing, you'll come up with the same answer for the single phase part of it, but it'll get so different if now this service was to come a 3-phase service because of the amperage, etc. Because when you come in an apartment complex, when you add in stuff like fire pump, swimming pool, now I need a transformer and all that type of stuff.
Right. So that would be 3-phase for apartments, aren't they?
Yes, sir. That's what I'm saying. You would need a 3-phase supply, right?
Yeah. That's what I normally see. Yeah.
Yeah. So I just wanted to clear it up. For your row houses, I don't have to worry too much about balancing the phases, because normally, you don't get all those heavy loads and stuff. But in essence for this exam, I want you to understand, you can have a worksheet that you can just be able to go right ahead and put the values in. And they say section A, area total watts. When we say 8,000, you just put that 8,000. But for your practice, I want you to quickly see how you can quickly go through, interpret this, and coming up with your total watts. Because I'm trying to give you a way that you could work through this very swiftly. So let's go area for, well, Ms. Tracy again. I'm bringing this back to you. So I'm back on my steps. So after I finish my area, this is where the code told us any electrical space heating load provided for with a demand factor as permitted in section 62, plus any air conditioning loads with a demand factor of 100% subjected to rule 81063. Let's go to rule 81063. I want somebody to turn that. Rule 81063. I want somebody to turn to section 62118. But let's go to section 8106 Street Face. Section 8, 1063. Yeah, I put it on the screen. You see this new. It says, and the code told us from section 8200 is subjected to this. So we got to do this. It says where interlocks are installed to prevent simultaneously operation of electrical space heating and air conditioning loads, whichever is the greatest load shall be used in calculating the demand. I want you to look to the bottom of your paper on question 4. Question 4 says, note, assume that space heating and air conditioning loads for the individual units cannot be operated simultaneously or at the same time, and the unit have automatic control device. So we know they ain't gonna be operating the same time. So I need to determine which one of them is the greater. Before I could say, Ms. Tristan, before I could say, and I don't know what value, tell me the value your space heating is in your question. What the value your space heating in unit A is. Mr. Joseph, what is the value of your space heatings in unit A?
In unit A?
Yeah, what is the value of your space heating?
4,000. Both of them is 4,000.
Okay, and then what's the air conditioning? What the air conditioning value is?
Oh, sorry, I didn't press the mute button. One is 4,000 and the second one is 5,000.
Okay, so gents and lady, without applying to the rating factor, from section 62, and hopefully everybody got their finger on section 62. Section 62 says the first section 62. You should have that highlighted.
Yeah, but I remember from last night we would use the AC.
Use the AC, right?
Because we would use 100% of the AC, but then we would use a particular amount, a percentage of the space heating, which would not go over the AC's value. Therefore, we will have to use the AC.
Use the AC. So you ain't wasting no time. You don't know.
No, I tell you, I was practicing this day. I was ready.
All right, sir. Okay, good. So, Mr.
So,
Joseph,
Mr. Darwin, in my case, the space heating is greater, so we use the space heating.
Your space heating is what?
The wires is greater, so we use the space heating.
Okay, so let's go to section.
You gotta do the calculation first.
Let's go to section 62.
62, what it is?
118. Section 62, 118. It says the first 10 kilowatts is 100%. So what you want to do, and that's Mr. Who told me they space heating was greater? Who's that? Mr.
Lewis.
Mr. Lewis. So Mr. Lewis, what you want to do? Add up your total space heating. What you get with your total space heating?
It's only 8,000.
Your total, when you add them up, is 8,000.
Yeah.
All right. The code says, and what your air conditioning value is?
Was 4,000. One was 3,000.
So all right, so space heating, watch this now. You say space heating was 8 and AC was 7,000. Right?
Correct.
All right, so now I need to determine if my space heating is the greater one. So I go into section 62. Section 62 says my first 10 kilowatts I must use at 100%, right? Everybody follow me from section 62? I need to pull it up. Let me pull it up.
Pull it up, please.
Do I need to highlight this because it's important? You can see this. It's coming. You should have PGS. Mark the page. Something. Section 62. Section 62, sub rule 116. that's it. Yeah. 118.
That's 118.
118. Why you gone so far? There we go. You want highlighter if you have a highlighter as well?
You're trying to find sections to do?
No, I have it.
Oh.
Yeah. I didn't realize they're going out that far. Okay, 118. There we go. Here we go. Got a mark and everything. Okay. You see that? Or I need to take that out. Let me take that off. All right. So you, yeah. So you want to highlight? You want to highlight this? It says, and I can read right into it. It says, notwithstanding sub-rule 1, where heating installation in a building for residential occupancy is provided with an automatic thermostat control device in each room or heated area, the ampacity of the service or the feeder insulator, conductor, supplying heating devices only shall be based on the following. The first 10 kilowatts of connecting heating load at 100% demand factor plus the balance of the connecting heating load at 75%. So before, Mr. Lewis, before I can say space heating is greater than the air condition, it says the first 10 kilowatts, and this could be a little tricky. The first 10 kilowatts is 100%. Because your space heating value is 8,000, and that 8,000 is greater than the 7, you know you can use your space heating value. You got that, Mr.
Yes,
Lewis? You got that. So you know we're using the value of the space heating. However, let's do this. Let's say hypothetically, let's say we had a space heating value. A space heating value was 12,000. And I want you all to work this out. Space heating value is 12,000.
Give me a second, then, Mr. David. Question.
Uh-huh.
So now, like out of space heating is more than the air condition. We'll use the space heating instead?
No. That's what the code say. That's what the code says. I'm reading off the page. It says the first 10 kilowatts. How I get the 10? Huh?
You add up the two space heating.
Yeah, but how do I get to 10? I start from what? 1 to go to 10, right?
Yes,
I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it says the first 10 kilowatts of connecting heating load at 100%. And so my space heating is 8,000. I have to use that 8,000 at 100%. And I look at that space heating, 8,000, and then I look at the value of the air condition. the space heating is bigger than the air conditioning. That is why I'm using that. But I say hypothetically, and I want you to write this down. Let's say I have a space heating total watts of 12,000 watts. I want you to write that down. Space heating is 12,000. And I have an air conditioning value. Air conditioning value of 11,000. Well, let's drop it down lower. 10,000. Air conditioning value of 10,000. Let's go 11. Air conditioning value of 11,000. So 11,000. Air conditioning value. I want to make it interesting. I want to give you something to make you think. I have a spacing value of let me give you something to make it think. Let's have a quick calculation. So let's say I have a space heating total value of 12,000, leave it 12,000. And I have an air conditioning value of 11,000. Oh, that's still too easy. I have a condition value of 12,000. I have a condition value. Oh, give me a spacing value of 13,000. An air condition value of 12,500. 12,500. Let's derate the spacing. Let's derate that AC is 12,500. So the AC is 12,500.
That's still, but so the AC still will be more.
Because you got to use 100% of the AC. With the space heating, you use the first 10K, and then you find you add the
35%.
percentage of the remaining one, and then that'll still be less than the AC.
Yeah, that'll be 12,250
according to the code.
Right.
According to right.
So I'm using my spacing value.
Right.
No, sir. You'll be using
my
the
AC value. AC value.
Using the AC value, which is 250 less.
Right. Okay. So that's important. You see that. I'm intentionally throwing there because sometimes you think I could just look at it and I can say, all right, fine. I can clearly use one or the other. And that question that Mr. Lewis had, Mr. Lewis space heating, if you notice, was 8,000. Intentionally, I want to get Mr. Lewis thinking. But the code got you to say from 1 to 10 at 10,000. You got to see that. I want you to, let me say it again. From 1 to 10, you use at 100%, not 10,000. Because the code said the first 10,000 you use at 100%. So when we looked at the space heating value in Mr. Lewis unit, his space heating value was 8,000. The air condition value was 7,000. And so how Mr. Lewis interpreted, he said, okay, fine. Yes, Mr. Dowell, I understand. From 1 to 10, I use it at 100%. And so I looked at my 8,000 and I looked at my 7,000, and that 8,000 was greater that represent the space heating. You always look out for that, please, because you might get a curveball like that.
Mr. Dowell, question.
Yes, sir.
Will we have to show the workings why we chose which one, or just put that in there?
You could just put that in there, and that's the reason why I'm arming you here, because I only give it 15 minutes for you to do this. This part of it. This is a very piece of cake if you interpret. You got to interpret down pat. Yes, ma'am.
For the example you gave, which did they say they're using space heating or AC?
They're using the space heating because the space heating value is 8,000.
No, for the example where you gave 13,000 and
they use the AC.
Okay, go over that again, please, because I say the space heater. Do it again, please.
Okay, so the value of your space heating was 12,000.
You said 13,000.
13,000, and the value of the AC was 12,500.
12,500. Okay.
12,500.
Okay. Now I understand. I thought it was 12,000. Okay.
Okay. All right. Good. All right, Mr. Trainer, you got that?
You put the other 500 on the jacuzzi.
Yeah.
Okay. All right. So that's extremely important. And so in the interpretation of this, what the difference between this and section A is that you ain't gonna have no space heating in section A. And so two things you're gonna be looking out for. Two things you're gonna be looking for when you come and the question 4, look to check and how you determine if the spacing is greater than air condition. And then if you have electrical range, you gotta see that as soon as you turn the paper over. You know you ain't wasting no time. You cannot waste no time. So as soon as you turn the paper over and you look in unit A and you say, I do not have no range, my air condition is the greater. I know I using my water heater for jacuzzi at 100%. I know I using my tankless water heater for 100%. And I know because I do not have no electrical range and I have other loads, once those other loads exceed 1500 watts, the first 6,000 we use at 100%, and the remainder we find 25% of them, add it up, and we put it in there. Any question with that, Miss Thurston?
No question.
No question, Mr. Lewis.
I understand.
Okay, Mr. Turner. So, Mr. Lewis, I coming back at you. I want to know what is the value of my other loads, Mr. Lewis, from your paper.
I calculate that now.
Huh? There's a B part of it. I'm trying to go ahead slow with it.
So, Mr. Darwin.
Yes, sir.
All right, I didn't get all these things in the column, right? I have 8,000. You say like you say the space heating is the 4,000. My AC is 4,000, 3,000. So in this one year, me using the AC, we using the space heating, the space heating greater than the AC? Is what you saying?
Yeah, according to section 62. You say your spacing value is how much?
8,000.
And what's your air conditioner is?
7,000.
All right, so we use the space heating.
Right. So in that column, my AC column, I have 2 zeros.
Yes, sir.
And the range 2 zeros.
Right.
Okay, so I think me and Mr. Turner have the same question.
Okay.
So we have a water heater, which is a jacuzzi at 1,500. So we use that at 100%.
Okay.
What should be zero? Hold on. What should be 0 too?
No. Water heater for what?
The jacuzzi.
What the code say, Mr. Turner? Go to section A200. Any tankless water heater or water heater for swimming pool, hot tub, or spa, the demand factor of how much? 100%. In
So
doubt,
that remains at 1,500.
yes, sir.
Right. Okay. Then we have a tankless
100%.
at 2,000.
So you
Then
put
the
that,
only other load we have would be a clothes dryer. That's only
water
500.
heater.
That's only 5,000.
all right. Do you have electrical range?
No, we
No,
have no
sir.
range. So we use that 5,000 because it doesn't exceed 6,000 watts.
That's correct.
So our other loads will be the
Clothes dryer.
clothes dryer. And the jacuzzi.
No, Mr. Turner, pull your code book out. Go to section A200. You don't have to, at this point, you don't have to remember it verbatim. Go to section A200.
Is a hot tub and spas. Tankless water heater.
Use them 100%.
So that remains the same then.
Yes, sir. You use them at 100%.
I see it now. So the clothes dryer would be our other loads.
Yes, sir. One unit A don't have no range. No, well, he's still in over unit A. So So, because we have almost like 11 different questions out there.
So, Mr. David,
Yeah, I'm
since
listening.
since the close dry is 5,000, right?
Uh-huh.
But it didn't exceed the 6,000.
So what you put in?
So I should stay the same.
That's what the code say, yes, sir. Any load provided for, in addition to those outlined in item, I want you to get familiar with reading that code.
Let me back and forth.
Back to the code, yes, sir. This is how you I said you back to the code. This is how you drill it in your head, you see?
Don't flip. Wait.
Except any load provided for, in addition for any load provided for that have the rating in excess of 1,500 watts, in addition to those outlined in item 1 to 5 at 25% of the rating of each load if a range has been provided for, or 100% of the combined load up to 6,000. Your combined load is only one. You say the total is how much? 5,000. What your value is for that range?
0.
Yo.
For your other load, the closed drive, what the value was?
5,000.
So 5,000, it says 100% of the combined load up to 6,000. Your load don't exceed 6,000.
So that remains the same.
5,000, so you put that in as 100%. You put that 5,000 in at full. And only if you had other loads, once you exceeded 6,000, you find 25% of it you would add it to that 6,000.
So, Mr. Lewis.
Yeah.
So the total load is 24.5 for unit 8.
Yeah.
All right, cool.
All right. And so we do the same identical thing over an apartment and unit B. However, you got to take into consideration now, if I have electrical range, if I have enough space heating, how I address that. And that is what I want you to get familiar with looking at. I look at my area divided by 90, tell me my total watts. But let's look again. So Mr. Lewis and Mr. Turner came up with 24 plus 1,000 watts. You divide that by 120 times 2, and that'll tell you the minimum ampacity of the feeder to unit A. You go over and unit and B, and you do the same thing. You cannot spend no more than 3 minutes figuring out these total watts for the feeders, because you don't know how to do this from the house. So we know 2 9s are 18, 3 9s are 27. So when I look at my area total watts, if it isn't more than 2,270, if it isn't more than, if it's 270 and less, I know my first 90, because it takes 3 90s to give me 270. My first 90 is 5,000. Each of those other 90s is 1,000. So that's 7,000. That's how I want you to see it. You ain't got no time to waste. Think about your 9 timetables. 3 9s are 27, 4 9s, 36. So if it ain't more than 360, if it ain't more than 360, that is how I want you to see. 5, 6, 7, 8. That's extremely important. Any questions? Any questions on that?
Hello.
Both of you understand? All right.
Like quoi c'est nèg? On connaît ça femme qui passe qui va là non nèg.
Okay. Uh-huh. Uh-huh. First range. As an other load. So the question asks, if I have 2 ranges in one of the units, how do I address? The code is very specific. Any electrical range load provided for as followed. I'm reading from section A200. Any electrical range load provided for as follows. 6,000 watts and highlighted in the same room for a single range. Right, up to 12K. And 40% of the amount in excess of that 12K. Right, and so if you have other loads, once you have a range, you just find 25% of them. We good? Because I want dive. We should have section A or the feeder for section A and the feeder for section B unlocked. Anyone have any difficulties with maneuvering into this? Mr. Lewis, I want you to tell me what is your total watts for unit A, your total watts for unit B. I want you and Mr. Turner to be able to tell me what the value was you use for the space heating in unit B and what the value you use in unit A. I can rub this board, clean it up, and I can dive right in to show you how we find the minimum capacity of the consumer service feeder.
You taking pictures again before you do that?
Oh, no, for goodness. We can get you right now. When I just again, Robert, say you want to take a picture. All right, we can get you right now. Oh, I see you squinting, man. You call it. Let me tell you the first now. All right, so we can throw the pictures, Mr. Grant, inside the chat. Throw it in the chat. Some of this good stuff off the board. Let's call in for some practice, Mr. Grant. Speed.
Pardon me?
I say, let's call for some practice on your speed.
Yeah, yes, sir. Yes, sir. Yes, sir. Definitely.
You can have the knowledge. You can know where to go to find it, but you need speed. And so if you practice, that's one of the primary reasons I'm doing it like this. You will see now, once you lock down the calculations and you understand how to calculate the minimum capacity of the service feeder, you'll see how easy it is when we come to knocking out the distribution board and the panel. So Mr. Turner, Mr. Lewis, I come to you all, get ready. I want to know what my total watts is.
I ain't ready yet.
No, man, listen, you ain't ready yet. What's going on with you? Get ready. And I come to you, you gotta be ready to tell me what is the total watts? Unit A. What is the total watts for unit B? You tell me if you use space heating.
So, Mr. Dava,
Yes, sir.
if you have a range, the AC still is get used at 100%?
Yes, sir. Ain't nothing changed.
Okay, so
Yeah.
am I section, am I unit B?
So I want you to tell me that. Give me a minute. I want you to tell me that in a minute.
All right, cool.
Uh-huh. All right, tell me if you all can see the board. Ms. Tracy, I want you especially see this. I think everybody else was here last night. Tell me if you can see this, Ms. Tracy. Mr. Turner, you can see that?
Go more to the right.
Uh-huh.
Tilt the screen up. Oh, down. Down. Too much. All right, that's cool.
All right, Ms. Tracy, you there?
Yes.
Okay, you can see this drawing?
Yeah.
You can see it? Okay. So this I hate to say old fashioned, I get nervous when I say old fashioned. So this is an old fashioned way how service was built back in the day. All right. Nowadays we have the weatherproof or the stackable meter combos. But the question is asking us, and we have unit A, unit B, and the house load. All right. It asks us to find the feeder to each unit. And so some persons told me 75 amps, 75 amps for the house because their load was 18,000 watts divided by 240. That is where they get the 75. The question didn't ask us to do a riser diagram, but I must show it to you how it would look for you to submit down to the ministry. So what we did, we did our calculation because they told us our total watts for our house was 18 divided by 240, and we know that we have 75 amps. Question only asks for the minimum capacity to feed it to the house. It ain't ask you for the wire size. So you don't have, for the exam purpose, you don't have the waste time going to table number 2 to tell me the wire size. You don't have the waste time showing me this drawing. They only ask, if the question read, if the source for all loads a single phase 3 wire, calculate one, and they see they have it in bold, the minimum capacity of what? Of the following: the feeder to each unit, the feeder to the house, and the consumer service wire. That's all they ask you. And so we found the feeder to the house, the minimum capacity of the feeder to the house, to our calculation, because they told us calculate it. Right, they told us calculate it. All right? Told us calculate it. They ain't even tell you in a, hey, Ms. Tracy, they ain't even tell you in accordance with the code. So this one for Ms. Tracy. Ms. Tracy, you see me? They ain't even ask you what addition. Why? Because they already challenge you. From in section 8200 again for the single dwelling, they don't challenge you that. And they've been specific why they say in accordance to the code. And that's why you laid that code thing out. That's why we come and question 4, we challenge you for some other stuff. The other stuff is how you interpret the space heating, and how you utilize the demand factor from section 62.118, and then how you interpret if I have a range or if I don't have a range. That is one of the key reasons they challenge you over here. So the first place we found the feeder to each unit, feeder to the house, and now the feeder to each unit. That's these lines coming down here. Straight to this question for you. You ready? Straight in.
Yes. Yes, I'm ready. Sorry, my mic was muted.
Okay. All right. So we found a fetus to the house and to each unit. My question to you now, C part of the question asks us to find the consumer service fee, right? My first question to you, ma'am, if we put small wire, small conductors on these lugs, would they burn up? That's for Ms. Tristan.
Do that again. You had froze. You had frozen.
Okay. I froze, sorry. I say if I put small feeders or small wires, let's say this house only needed number 14. If I put this number 14 on this log here, L1, L2 in the neutral, will they burn up? So Joseph, I want you to look at that because I coming after you. You wasn't here with me last night.
You put the number 14
on the log.
On the lugs.
Yes, ma'am.
To supply the panel.
I didn't practice and I ready for you.
Yeah, the supply, hold on, Mr. Joseph. The supply, let's say the house load. Let's say the house load only came up there. Let's say it came up to 30 amps, right? I can use the number 10 wire. Could I put the number 10 wire on these big lugs?
No.
Huh?
No.
Why?
I think there's a minimum that size wire you can have as a consumer service wire somehow.
I mean from the service here. I mean coming from your house. You won't say you think you walk up with the wires come up the top. I ain't coming to that here. I'm talking my trough that I have down here, where I can have feeders, coming from unit A and unit B to get connect up. I'm saying hypothetically, let's say my feeders coming from unit A is a number 10. Could I put
No, I don't think so because they're too big.
Yeah, they're like that for you.
Tanner, mute yourself, Tanner.
Mute yourself, boss. We don't hear that.
Tanner.
Go ahead, boy.
Mute yourself. We try to get something there. Miss Jason, so you tell me the lugs will be too big, or the wires?
Yeah, don't they have a rating on these equipment to say the range of the size wires? So just follow that.
I asking you.
Well, I don't know the rate. I don't know the rating on the device, so I would say no because they seem too big at this moment. Okay. You look like you have a big lugs there for number 10.
Okay. All right. So let's go out into the field. So if I walk outside my house and look at my service coming in from BPL, right?
Mm-hmm.
And I put on my climbing boots and I carry 2 pieces of number 10 and I tie into the hot and the neutral. Would anything happen to, I do it in a safe manner. Would anything happen to that number 10 wire?
If you tie 2 pieces of number 10 to the lugs,
one to the neutral and one to the line, would anything happen to the number 10 wire? You can say you ain't sure. If you ain't, you can say that.
I thinking of the question you're asking, and I try to understand your question, but I don't understand your question, so I don't know.
You ain't, okay, so let me say, could you pull more than you could pull?
Can I pull more than I can pull?
Yeah.
No.
No. Okay, good. Right. So we getting someplace. And then my question to you: the breaker protects the wire, or the wire protects the breaker?
The breaker protects the wire.
The breaker protects the wire. Okay. If I can't pull more than I could pull, it means when I tap on something that is given, I only could pull what I could pull. Right?
Correct.
And so that means nothing can happen to the number 10 wire. If If I tap on those big lugs. Because I only can pull what I can pull.
Okay.
You follow that? I want you to follow that.
Yeah.
I only can pull. So if I go into this big panel that have these big lugs, without going into a break, and I just tie onto the lugs. I just tie into the lugs. I can tie in, but I only can pull what I can pull, what I'm rated for, what I can pull. So if that number 14 or the number 10 or the number 3 wire, let's use the number 10. If the number 10 is good for 30 amps, it can only pull number 10 before that start to burn. I mean 30 amps before she start to burn off. So I go back to you. Does the wire protect the breaker or the breaker protect the wire?
The breaker protect the wire.
So I want you to think carefully about it now.
The breaker protects the wire.
I want to think inside your panel. The breaker protect the wire. Okay, all right, okay. That's why we derate. That's why we derate our breaker. Yeah. So I want you to understand that. So we could actually take number 14 wire. I could even take telephone wire and tie onto those big lugs, and I could get power from it, and nothing would happen to that one time, pulling more than what that is rated for. All right. I mean, I seen it in play. I always believed it, but I seen it in play when I've been in Cuba. So you see some feeders in Cuba, you know, because they didn't have a lot of electric there. I'm like, wow. But if you want to see it and play in the Bahamas, I normally like to use the Super Value warehouse on Michael Road, that big warehouse that all they use for storage space. Have a little small 60 amp service. Yeah, believe it or not. And so, Ms. Tracy, I want you to see that a lot of electricians get nervous when they see you tying in here. Then my service feed is coming in. It's a 4 odd, and I use them some number 4 or 5 tying in for one of the units. You could do that because you can only pull what you can pull, and that is why you have that disconnect switches. And because your meter does not pull anything, is why the meters on the top of the line, when you look at a meter, you see line, load, is only to the bottom of the disconnect switch. Bottom of the disconnect switch is where the protection starts. It's only to the bottom of that disconnect switch is where that protection starts. Because the meter rated for 125 amps, let's say hypothetically in residential, the trough, in this case, may be rated for 250 amps, depending with the amperage we calculate. Your disconnect and your panel will probably be rated for 125 amp, 250 max, depending on what size the amperage comes. But I want you just to understand that part. Mr. Lewis, we ready? And
Yes,
so
sir.
the question, Mr. Trainer, that question 4 is asking you, all they asking you is for the minimum capacity of the feeder to each unit and the minimum capacity of the feeder to the consumer service wire. That's all they asking. That's all they asking you. And so from section A200, let me fix this so we can see. I can dissect the board into two loads. I'm using the calculation provided to me by Mr. Turner and Mr. Lewis. And so I can call this A, unit A, and unit B. And we'll put over here again, unit A, what total watts? Unit B, total watts. And so the total watts in unit A, Mr. Turner or Mr. Lewis was what?
8,000 watts.
Somebody talking about Jay. Total watts. I want a total. I want the area. I want the total watts. When you finish your order,
24,500.
All right. Now we talking. How much?
Okay.
24,500.
24,500 watts. That was the total watts that Mr. Turner and Mr. Lewis came up with for unit
Yeah,
A.
that's right.
All right. What was the total watts for unit B?
I scared.
Unit B was only 23,800.
23,800 watts. Okay, that's the total watts. And so, gents and lady, I want you all to follow how this is dissected, utilizing the code.
Well, I go on someplace wrong.
All right. Looking at Irene from the code, section 8200, sub-rule 2. And Mr. Turner, you got to find where you're going wrong. Section 8200, sub-rule 2. It says the calculated load for the consumer, and I want you to highlight this. The calculated load for the consumer service or feeder conductor supplying 2 or more dwelling units of row houses shall be based on the calculated load in the dwelling unit as determined in accordance with sub-rule 1, excluding any electrical space heating and any air conditioning loads with the application demand factor to the calculation loads as required by Rule 8-20023. And all that is saying to you, that's what you use. Okay? Everybody follow that? Let's go down there and let's see what they're telling you. So it just directed us down to section 8202, sub-rule 3B to E. Mr. Tyson, you follow me?
I'm following.
I want you to see why people think you using, and somebody asked the question, well, we ain't never, I think Turner asked, we ain't never use section 8202. Mr. Turner, see what the code just said? It says, if I want to find my consumer service feeder, I must go down to section 8202, sub-rule 3B to D, and deal with it. And so that's how I got down here. Section 8200, sub-rule 3, it reads, the calculated load, and you want to highlight it, for the consumer service or feeder supplying 2 or more dwelling units shall be based on the calculated load obtained from sub-rule 1A, that's upstairs. So my calculated load obtained from sub-rule 1A, Mr. Turner told me, Mr. Lewis confirmed it, and unit A was 24,500. And unit B was 23,800. So I obtained that, sub-rule 1. And then it goes a little further. And I want you to follow how important this is. A, excluding any electrical space heating load and any air conditioning load, the load shall be considered to be 100% of the calculated load in the unit having the heaviest load. Let me read it again. The calculated load for the consumer, service, or feeder supplying 2 or more dwelling units shall be based on the calculated load obtained in sub-rule 1A and the following. They say excluding, take away. That's what that means. Take away. If you use space heating or air conditioning in unit A or unit B, take it away. So let me ask, everybody understand that? Anybody do understand what that said there? Section 8203. Okay, good. So I asked Mr. Lewis, what did I use in unit A? Space heating or air conditioning?
Space heating.
Space heating, and what the value is?
Total value is 8,000.
All right, so I take away 8,000 on 24,500. What that leave me with? What that leave me with?
16,500.
All right. And I go in unit B. What I use in unit B?
AC.
I use AC. So what the AC value was?
7,500.
7,500. And so I took that away from 23,000. What I came up with? What I came up with when I took the 23,000, 7,000 from 23,000. See, 16,008. So Louis, what you came up with?
Calculating now, Mr. Darwin.
Mr. Darwin.
16,300.
How much?
16,300.
16,300?
Yeah.
You say 23,800, right? Minus 7,000.
7,500.
Or seven. So you say 20, hold on. You say 23,000, how much? 500?
23,800.
Yeah.
The ACs was 7,500.
Oh, not seven. Okay.
Oh, Mr. Darwin, could you move the screen more to your left? A little more than that. A little more.
Okay. That's good?
No, I gotta go over some more. I can't see the one more to your left. All right.
That good?
Yeah, that should be good.
All right. So when I take away 7,500 from 23,800, what I come up with?
16,300.
16,300. What? Okay. All right. And so now I'm reading again. I'm reading section A200 subrule 3B. It says, after I take away the space heating and the air condition, I use 100% of the unit having the heaviest and 65% of the next two units. I ain't talking about the house. So because I only have one unit, I'll use 100% of the heaviest of the unit being the heaviest one. So in this case, I will put this here. Consumer service total watts. I label it consumer service total watts. I using 100% of unit. And so which one of the units is the heaviest one after I take away the space heat and the heat and the AC that I use? So that means unit A is the heaviest one, right?
Right.
After I took away the space heating from unit A, the AC from unit B, I left with a value from unit A of 16,500. So the code told me I must use 100% of the one being the heaviest. So I use 100% of unit A, which is 16,500 watts. And then I use 65% of the next two units. In this case, it's only one unit left. So I found 65%.
Which is 10,595.
Okay. 65% of unit B, which is equal to 10,000, how much?
595.
All right. And so I'm reading again on the code. It allows me to go right down. It goes right down to tell me if I have 2, 3, 4 units, etc. All right. I only have them 2, so I go down to the next step. I ain't got to the house yet. No, sir. I ain't got to the house yet. I can show you where I can get to the house. Mr. Ingram said, Mr. Darwin, well, I said, why you ain't touched the house yet? The code ain't told me to go to the house yet. I can show you where we can get to the house.
Mr. Darwin,
Yes, sir.
you could turn the laptop, the computer, please. Yeah, right there. Thank you.
Good. All right, no problem. All right. So I can just read 3 a little bit. It says 65% of the loads to those specified in item 2 plus 40% of the sum of the calculated load in the next 2 units having the same or the greatest 25%, and they go on and on. Now you come to B. This was B, and I want you to highlight B because this is extremely important. I want you to highlight B, section 8, 200, subrule 3, paragraph B, highlight it. It says, if electrical space heating is used, the sum of, and I want you to put all, the sum of all the space heating loads as determined in accordance with the requirement of section 62 shall be added together to the loads in accordance with item A, subrule 1, subrule 8106. And we know this before. We say, if I have space heating and air condition, if I have space heating and air condition, and they can be used at the same time, whichever one is the greatest, we must make provision for it. So we did it over here when we find the feeder for the individual units. Now we took them out. Now the code said we got to put them back in. But before we put them back in, we need to add up all the space heating. We have to add up all the space heating from unit A, along with the space heating from unit B. Add them up, apply section 62-118, and then add up all the air conditions, unit A and unit B, and then look at the values to see which one is the greater. And so I can say total space heating and total air conditioning. Mr. Lewis, Mr. Attorney, you ready? Let's go. AC total, watts, space heating, total watts. AC total watts in unit A was how much?
8,000.
8,000. And in unit B,
Sorry.
8,000?
You're 7,000 in unit A.
7, the AC was 7,008. And unit B?
Unit B was 7,500.
7,500. So our total AC watts is equal to 14,500. All right. What my space heating total watts was in unit A?
Space heating was 8,000.
8,000. And unit B?
B was
B was how much? How much was B?
7,500.
7,500. So my total space heating watts came to 15,500. 15,500 watts. But before I could say space heating is bigger than air conditioning, I derate that space heating. And so the code tell me the first 10 kilowatts I use at 100% and the remainder 75. When I minus 10,000, and I minus 10,000 of 15,500, because I know I use it at 100%, I go find 75%, sorry, 75% of 5,500. Somebody give me a value. What value you got, Mr. 4,125. 125 plus 10,000. They give me my space heating total value of 14,125 watts. Now, I look at my space heating value, and this is what I was saying, Ms. Tracy. By the naked eye, I thought I was going to go ahead and use my space heating value of 15. Only because I did my derating factor. When I did my derating factor, I came up with a value of 14,125 for space heating total. And for my AC total, I came up with a total of 14,500. So in my total watts column for my consumer service watts, I have to use the air conditioning value. And so I put that AC value in. AC total watts is what we use to put and find our consumer service feeder. which is 14,500. Any questions with that, Mr. Lewis?
I follow.
You follow? Okay. We go down. This one for Mr. Ingram. Mr. Ingram, it says D. Except as permitted by sub-rule 8, 106, 11, any electrical vehicle supply equipment loads not located in the dwelling units shall be added with a demand factor as specified in table 13, table 30, 38, and with a demand factor of 75%. I want you to see how important this is, gents. I want you to see how important this is. So I tell you, if you have that electrical vehicle, even though I want you to see in the individual units, if you had them, you use them at 100%. Same identical thing you'll do when you use it for finding a consumer service feeder. In this case, Mr. Lewis, did you have any electrical vehicle equipment?
No, sir.
Okay. Sure you ain't had none?
No, we ain't had none.
Okay. Mr. Ingram, I expect you to tell me, Mr. Darwell, you ain't said something right. Remember I tell this question for you? I said earlier in section 8200, when we had, Mr. Roll, I want you to pick this up. Tracy, I want you to follow this. In section 8200, we said when we had electrical vehicle charging equipment, it told you use it as 100%, outright. You got that? It come back here now, it tells you, and I'm reading, except as permitted by sub-rule 8-10611, any electrical vehicle supply equipment loads not located in the dwelling unit shall be added, with a demand factor as specified by table 38. They ain't telling you 100%. You see that? So if you had that, now you got to go to table number 38 and see what table number 38 tells you. All right, sir? So be careful of that. Be careful. What table number 38 tell us? All right. So you see how tricky they can get you? So you got to follow the code. That's why I'm saying, when you read it, I guess when you say, Mr. Darwell tell me this, no, I'm following the code, what the code tell you. Now, because remember, this might be that parking lot I talked to you about, when you talk about apartment, Miss Tracy bought, she bought a Tesla. Now, she said, listen, I buy my Tesla and I probably can have two of them, or I won't be able to charge them from two different locations. You see? Now the code tell you how to address it. Or you building your apartment complex. Now I say row housing, your apartment complex. The code been specific how you go ahead and calculate. Because my apartment complex, I have 40 houses, 40 units. And I need 40 stations for that. That's totally different. And that is some of the different things that you know. When you calculate your service for the apartment, I compare with row houses, Ms. China, Ms. Chasten, this is how they differ. This is how they differ. So in this case, we did not have that electrical charging equipment. So we go down to the next one. Again, now, Mr. Ingram, this is you, and this is where the house load. It said, in addition, any lighting, heating, and power loads, not power load, that's the house, right? Because they told it in watts. Power loads not located in the where? Dwelling unit. They told me that was a house. So don't tell me that house is a dwelling. Not located in the dwelling unit shall be added with a demand factor of 75%. And so all I say here, house load, of what the value of your house, Mr. Turner? Mr. Lewis? 18,000?
It was 16,500 watts.
Okay, find me 75% of that. 13,500. Okay, good. Give me my total watts, Mr. Lewis or Mr. Trader. Total watts. My total watts was I had 16,500 plus 10,595 plus 14,500 plus 13,500.
Now you can tell the screen down for me, please.
Yes, sir. Yeah. That's good?
Cool.
All right. So give me these values.
55,095 watts.
55,095 watts. All over 120 times 2. Give me amps.
229.56. Sorry, 229.56.
Yes, I told you give me a transformer now. How much is this? 200?
2,029.56.
Man.
I know, I sorry, 200.
What it is? 229.562 amps. So the minimum capacity of my consumer service feeder is 229.562 amps. This is where the points come in here. You found my feeder, my house, that's 2. And I found my feeder to unit A and B, that's another 2 plus 2 plus 2 plus 2 plus 2, that's 10. I give you 11, 12, 13, 14, 15, 16, 17, 18. I get 2 points for this. I only get 2 points for the final answer. If any which one of them wrong, throws the whole thing off. So extremely important. Any question with this? This is a mouthful. I mean, some person we blown fuse last night.
Yes, I have a question.
Yes, ma'am. Go ahead, ma'am.
The question says, find the minimum ampacity of the feeder.
Feeder?
So, yes.
Okay.
Right.
Okay.
Feeder, this is the... Okay, hold on, sorry. We on C. Find the minimum ampacity of the consumer's service wires, right?
Right.
So, this is the answer in the box?
C part asks you for the consumer service wire. C.
Yes. So
C asks you for the consumer service wires.
Yeah.
Okay.
So this 229 point, I can't see the rest of that.
229.562 amps.
That's the amps that you calculated. So
Right.
you're saying the amps that I calculated is the minimum ampacity of my service wires.
That's the minimum ampacity, but then your answer, because you got to go to table number 2 now, right?
Okay, that's what I asked him because you say you finished.
Okay, ma'am. Sorry. Okay. She's drive testing. She's drive testing. No, so the question let's look at the question. It's a very, very good observation. Let's look at how the wording and how they actually tap it at you. And you want to be mindful of this in essence of time. It says, if the source for all loads is single phase, 3 wire, calculate what? The minimum, and you see it in bold.
Minimum capacity.
Calculate the minimum capacity of the feeder to each unit. the feeder. Calculate the what out? The minimum ampacity. That's what they ask you. The minimum ampacity of the feeder. Right? Calculate the minimum ampacity of the consumer service wire. So what's the difference between the feeder and the wire? Did they ask me for wire size or feeder size? What's the difference between the feeder and the wire? Let's trace that for you.
I know. I thought they're the same.
The feeder, I feed this, and that's a wire. So they're the same, right? So what the question is asking us? They only ask you for the ampacity, Miss Tracy?
Yeah. And that's not the ampacity of the wire, though. That's not the minimum ampacity of the wire.
They ain't the minimum ampacity of the feeder?
No.
But it asks you, what they ask you?
They ask you, okay, let's
But the
go to
minimum one. What is the minimum
ampacity
ampacity?
of the feeder? This
Don't be scared.
calculation on the board
Yes, ma'am.
is the minimum ampacity of the service itself, not the feeder.
Okay.
This is what I am interpreting. But
Right.
you could tell me. So
And you're right.
now
I want you to defend. See, this we talk. I want let's
She's scared. She right.
put the case out. I want you to put your cases.
So if this the minimum ampacity of the service, now you have to find a feeder that correlates to this ampacity and find that minimum ampacity of that feeder.
And how I
that wire.
find that? And how
Go
do
to
I find that?
Go to table 2.
All right, that's all. So why you sound like you got bubble in your voice?
I hungry.
That's a way. No, you are correct. For C, you have to show me your calculations. But you got to go to table number 2. That's why we went to section 6104 when we talked about the minimum passing. You got to go to column number 2. That's why we went there. So yes, you take that 229.562 over the table number 2, and you tell me a minimum ampacity. Gotcha? And so what you got, how much MCM? So what you came up with, Mr. Tracy? 300 MCM. How much you got, Bill? 300. 240. Okay, good. All right. I would send this presentation. I would send this presentation out. But I need you for next class, and I want to take a picture so you can send it out to them. What I will do also is actually send that presentation. I promised Mr. Turner I was going to send that to him last night. I did. I'll send that presentation with the steps. I want you to read a little bit more up on section 8200, so we can have that down locked. So you can have that locked. I also want you to have a centimeter ruler. I want you to look at table number 6. And I want you to look at table number 6. I asked one question last night for folks to tell me the difference between grounded and grounding. Grounded and grounding. Mr. Grant, you got the answer? Why you say go to section 0? Good.
I remember I read it when you got it on the board this morning.
Yeah.
But I mean this afternoon, but I can't remember what it said.
All right, no problem. I ain't gonna blow no more fuse. It was a mouthful. I want you to go over it because I want to talk when I come back. I want to talk a little bit of a grounding start and grounded start and grounding begins in your disconnect switch. And I want you to think about that close nipple coming from the meter. That's grounding or grounded. That's why I want you to think about that. Once you understand the terminology, and especially when you are you're thinking any day of going into this for Mr. Rule, going in with solar, you got to understand grounded and grounding. Extremely, extremely important when it comes to solar. Extremely important. And so where you use and how you use the terminology. I don't know if you ladies and gents sometime may be called upon to have the right technical reports that have implication to insurance, in particular, how equipment may have been damaged. Again, section 0 has with where you have definitions, has a good way where you can start with actually if you need to pull wording, definition, etc. from. So that's my 5 cents, God willing, for this evening. I have another question. Yeah. Piece about the electric car. Okay, go ahead. Okay. In the house or in the, tell me, talking about the row housing or the single dwelling? Okay. Right. 100%. Right. So if you read there, that's 75% of what I calculate this. My consumer service feeder. You would add it again. Yes, sir. You oversize it again. You got that? Yes, and that's why I'm saying it's so important because guess what? So gents and ladies, the question Mr. Ingram posed to me, he said, Mr. Darwin, sir, in my row housing, let's say hypothetically, unit A and B had two electrical equipment, right? He had 2 of them. And so the code told us we had to use them at 100%, right? Now, and that's when I was finding though, the feeder size to each unit. You got me? The feeder size of each unit. Now, when I come in to find my consumer service feeder size, I got to make provision. The code tells me because I try to find the wire size that could cover these 2 down here because I done using them at 100%. You got me? And so that's 75% that they speak about is for your consumer service feeder. Again, that's why it's so important when you look at the difference between the apartment and the row housing, and then what the apartment means. So the apartment complex may mean I have 200 parking space that need this here. They ain't inside here, they outside there. Ms. Jason, you got that?
I'm trying to understand now what you say. You saying now.
Let's look on the screen. Maybe say section A200 subrule 3. We say except as permitted by rule 8-106, any electrical vehicle supply equipment loads located in the dwelling unit shall be added with a demand factor as specified in table 38, right? And so when we went to table number 38, right? Mr. Ingram pointed out, Mr. Darwin tell us we only use 75%, right? They've been Pacific. But he asked the question, Mr. Darwin, how do I deal if I had an electrical vehicle in unit A and unit B, when the code told me up here in section A200, I use them at 100%. So I said to Mr. Ingram, yes, you have to use them for 100% because that's when you was finding the feeder to the individual units. You put them in just like how the code said to you. You put them in as 100% because you was finding the feeder to each unit. Now, when you come down to 3, you finding the feeder to the consumer service feeder. And because you find it in a feeder, the code tells you how to address that. I tell you at 100%, but they've been Pacific. 1 to 4, right, and that's what I'm saying. That's for 1 to 4. But what if you have 10? You're saying? Right, 1 to 10. So if you have, what if you do? How you deal if you have 10? That's over. And so instead of like you're 100%, because I did for each unit, I expected one unit to have 100 parking cars. And so that A unit might have 4 cars, and them 4 cars, I make provision for them. The first 4 you use at 100%, and the remainder you find that according to the ESA. Good stuff. All right. So, gents, ladies, I want ladies.
Mr. Davo.
Yes, ma'am.
I have a question too, Mr. Dow.
Okay,
I
go
have
ahead.
I have a question about that.
Go ahead.
This says electric vehicle supply equipment loads not located in dwelling units.
This be brand new.
Yeah.
So if in section 1 my equipment, my vehicle supply is located in the garage,
Right.
does that count as located in dwelling unit?
If it's located in my garage, and that is why when I use the scenario when you're talking about apartments and dwelling units, how you do the calculation and what is the difference between apartment and the dwelling. So the apartment might just have a general parking area. Follow me? And in that general parking area, they know they can be high tech. Everyone who there have either have an electrical vehicle, or they say, fine, I can make provision for 8 or 9 electrical vehicles. They give that choice. You as an individual say, well, fine, I know I have my electrical equipment. I'm putting it in my garage. Now that's totally different from being out in the general parking. You see, for example, your dwelling home. You put a garage, your row housing, you put a garage. That's totally different for if you can leave one outside the gate or in your big parking lot. So if a person come over to a party to plug inside, that is calculated totally different. So the one in your big parking lot is for when folks come over. The one in your garage, that's where you store in the Tesla. Gotcha?
Yeah, so I wouldn't count that. I wouldn't, for this D8202D 3D, I wouldn't count the one in my garage in this D. I would just count the one in my parking lot for everyone who come at the party.
No, you still have to count that. You still would have to count, because this is what D says. It says, except as permitted by Rule 8-106. You see that word there, any?
Any electric vehicle supply load.
Wherever you have it, miss.
But it say not located in dwelling units.
Hold on, let me go. Any electrical vehicle supply loads not located in a dwelling unit shall be added. You very much correct. Yes. Yes.
Okay.
Yes. No, you very much correct. My bad. You won't include that particular one.
That garage one. Okay, understood.
Yes. But let me go a little further though. Any electrical vehicle supply loads not located, watch this now, in a dwelling unit. You ain't calling your garage that is detached from your house, a part of the house, right?
No.
No, so that'll be not located in the dwelling unit, even though it housed.
But if the garage attached to my house, that's part of the dwelling unit. But if it's not, okay, got you.
Yes, that's important, because you have some of these big timers say, hey, they build a house for their car.
Yeah.
You see what I'm saying? So that's actually, I just want to make that clear.
Okay.
Right. Okay, good.
Thank you.
You're welcome. Alrighty. Somebody else had a question? No, Mr.
I had a
Storm,
question on the range. I had a question with my range. So I have 2 ranges inside my question B. I mean, in my house B, and it has one was 18,000 watts and one was 6,000 watts. So what I should do is, should I take the first 12K and find the remainder of the remainder of 6,000 watts for the 8,000 watts, right? Find the 40% of that remaining 6,000 watts, right?
That's what the code says. So I got 2 range, right?
Yes.
And I'm reading. You follow me? Here we go. Code say any electrical range load provided for as follows: 6,000 for a single range, plus 40% of any amount by which the rating of the range exceeds 12 kilowatts. So your first question. My first range was, what's the value of your first range?
18,000 watts.
18,000. You take away 12 from the 18, the first 12 is 6,000. You find 40% of the remainder. Tell me if you get that.
Yeah, I found 40% already.
All right, so you add that 40% to the 6,000.
To the 6,000.
Yep. Let's go
So
again.
12K is automatically 6,000, right?
Yes, sir. From
And then
from
you add-
1 to 12 is
Yeah,
automatically.
1 to 12, 1 to 12. So my question isn't, but the first one. My question is more so on that second range. Do I just turn that into other load
Yes, sir. You got it.
and use 25% of that?
Yes, sir.
Okay, that's all I want to make sure.
Okay, why? But why? You can ask me why is that, Mr. Darvel? So you let me see. It says any electrical range load provided for as follows: 6,000 watts for a what? Single range. So you want to highlight that single range. That's the why part of it.
Okay.
Okay.
Mr. Double.
Yes, sir.
That's Kenny Bo. He can't unmute his mic, so he can't speak unless you unmute it. Well, he was trying to ask a question earlier, but he
Who's
couldn't.
that?
I think it's Kenny Bo. Am I saying it correct?
Bo?
Yeah.
Oh,
Gotta unmute him.
so where I got
And just to reiterate with the range, what he was saying was how there was two ranges. The first one, you calculate the regular range, you do over that certain amount and a percentage. And the second one, you just use 25% of it.
So your first 12 for the first one.
Right.
6, right? And then 25% of the second one. If
Yeah.
the first one exceeds 12,
then you gotta
you find 40% of the amount by which it exceeds that and add it to the 6,000.
Right.
Who you say I have mute?
That was
The Bull?
Yeah, Mr. Bull.
Okay, then intentional, Mr. Bull. Fine, Amy probably left. Mr. Bull. He left?
I think he left.
He left. Okay. All right. Sorry about that. Put something in the chat. Say, tell him I'm paying attention. Please. Sorry. All right. So what I want each of us to do is make sure I have a centimeter ruler, have a blank on the plan for our next class, so we can get that all sorted out. We can do that calculation, and if you could also have a blank copy of the distribution board, so we can start filling that out. All right. All right. Okay. Good night. Yes, sir.
What we need, Mr. Novel?
Say again.
What you say we need?
You can need your centimeter ruler, the blank copy of your of the plan, as well as a blank copy of your distribution board.
Where are we getting up the plan?
You could print it off from the from out of the you could print it off from out of the VLE, or it would have been part of what I would have scanned and sent from the question paper.
Okay.
Yeah. You get it from there.
Plan and distribution board.
Right. And then a centimeter ruler. All right. All right.
The board should be in the stuff you send as well.
Yeah. All right, so that's my 5 cents, gents and lady. No other questions? You got me running into some place called Mangrove Key tomorrow. Nice place to tell me. Wait, won't stop. All right. All right, so everyone have a good evening. Be safe. If you got to get on the roads, be safe. God's willing, Friday, same time. We're doing it online. As usual.
Hey, Mr. Darwin.
Hey.
I think may break it and chip way, and I don't even know if people are good. We said it right now.
I guess I got some people over in Florida. I have them fly over real quick.
Wait, listen.
You guys got to keep at it, Mr. Chairman. Don't give up. You got to keep at it.
Yeah, well, I get right back at this tonight.
Yes, sir. Ain't no trouble. All right. You all have a good evening and take care. God's willing on Friday.
Yep.
All right.